Hello everybody and welcome to another ATC Maths and Science tutorial video. Today we will be discussing cubic functions, more specifically how to factorize a cubic function to find those tricky to find x-intercepts when we need to sketch a cubic graph. And we will be using the technique of the remainder factor theorem in order to factorize. Now, there are other methods to factorize, such as grouping and synthetic division. There are videos in the list where you can, if you prefer to use grouping or if you prefer to use the synthetic division method, where you can go ahead and check exactly how to use those strategies in order to factorize a cubic function. But for this video, our focus will be on the remainder factor theorem. So let's just jump straight into it and begin. So today we'll be factorizing the following equation. We'll be working with f of x equal to x cubed minus 8x squared plus 17x minus 10. Now, one of the things I like to do whenever I'm solving any problem is sort of list down in terms of steps what we would like to do. So the steps for solving here, so it gives us an idea right at the start what we're going to be doing. So step number one in the solution will be to use remainder factor theorem. Step number two will be to follow this sort of like a blueprint that we're going to be using in order to find the factors. We're going to say 0 is equal to x minus a into x squared plus bx plus c. And then finally, step 3 would be to factorize our trinomial into the two brackets, x minus something, or plus or minus something, right? Some number which we need to figure out, and that's obviously just factorizing this trinomial. So let's follow this three-step plan in order. Let's begin with using the remainder factor theorem. So how do we use the remainder factor theorem? So the remainder factor theorem requires us to substitute a value x equal to a, some number a, into the original equation, so f of a, so that we end up with f of a being equal to 0, as in no remainder. Now, how do we know what a is going to be? Because a can be any number. I mean, there's an infinite number of numbers for us to choose from. We can't just randomly guess as to what we want to pick for the value of a. So this is where our theory comes into play. A will always be a factor of the constant in the equation. So in this case, a factor of minus 10, which means that a will either be plus or minus 1, plus or minus 2, plus or minus 5, or plus or minus 10. How do we decide which one it's going to be out of this potential 8 numbers? This is where a little bit of trial and error comes into play. However, let's note this. When it comes to examinations, there's this term I love to use called exam theory, where it's theory that's unique to answering questions in an exam. Because as we know, whatever comes out before will come out again. There's a certain degree of repetition in most examinations. You will find that if you're running through past year paper questions, that whenever they're looking for this value of a, it is usually from the set plus or minus 1. It is deliberately designed to be one of those two values. Now, will it always be one of those two values? No, we can't say that for certain, but we know that that's where we would like to begin. So between plus and minus 1, let's choose plus 1. Let's see if this gives us the 0 that we want. So we will say f of 1 is equal to 1 cubed minus 8 times 1 squared plus 17 times 1 minus 10. And this gives us, when we do a quick calculation, it gives us the 0 that we're looking for. So that's step number 1 sorted out. We've used the remainder factor theorem. Now we go on to step 2, except in step 2 we now have the value of a. So what we have so far is the following. We have 0, which is what we let the equation equal to whenever we're trying to find x-intercepts. I'm sure everyone knows that, let y equal to 0 and solve for x. So we now have the value of a. So it's x minus 1 into x squared plus bx. Now, the value of c is the number we want to find next. And how will we find c? We will find c through analysis. As in, we know that when we factorize any equation, if we multiply this equation back, as in x times x squared, x times bx, minus 1 times x squared, minus 1 times bx, and the constant obviously being multiplied as well, it should take us back to the original equation. So let's consider the two constants that we should have, which is minus 1 and c. If I multiply these two values, and I say to myself, okay, let me multiply 1 times whatever c is going to be. This should give me the constant in the original, which is minus 10. So this means that the value of c can only be one thing. C has to be plus 10, because minus 1 times 10 is what gives us what we were looking for. I'm just filling that back in. All right, now we're going to use the same analysis approach in order for us to find the value of b. When we multiply this equation out, it should give us the original equation. So let's do the following as a step. Minus 1 times x squared gives me minus x squared. X times bx gives me plus bx squared. These two x squared terms, when I add them together, has to give me the x squared in the original. It has to give me that. So this is equal to minus 8x squared. If we divide all the terms here by x squared, the x squareds would cancel off, and we'll be left with minus 1 plus b is equal to minus 8, which means that b, solving this linear equation, is equal to minus 7. Now we can go back to our equation and fill in the value of b. So we now have 0 is equal to x minus 1 into x squared minus 7x plus 10. The second bracket being a trinomial, we can factorize this into x minus 2, x minus 5, like we normally would factorize a trinomial. Now to find the x-intercepts, we set each of the brackets equal to 0. And solve for x. So x is equal to 1, x is equal to 2, x is equal to 5. So my three x-intercepts would be 5 and 0, 2 and 0, 1 and 0. And we have our x-intercepts sorted out.